Okay, this is the video quiz or test review for the test 5.2 on means. It'll be t-test and paired t-test. This will be question one or scenario one. So lead found in some paints is a neurotoxin that can be especially harmful to the developing brain and nervous system of children. Children frequently put their hands in their mouth after touching painted surfaces. This is the most common type of exposure to lead. In Flint, Michigan, many have alleged that the amount of lead exposure is significantly higher outside than inside. That might be important because we were talking about higher, so that might give us a direction. We'll see if that's the case, and have recommended that daycare center no longer allow children to play outside due to the amount of exposure to lead. So there's a claim that you get more lead exposure if you're outside than if you're inside, and that it's dangerous to children. And so that's a curiosity that we're going to look at. The city of Flint has commissioned a study to explore this claim and randomly selected 9 children from urban daycare centers to conduct the study. The hands of the children were wiped clean. They were then allowed to play outside for 1 hour, after which the amount of lead in micrograms on each child's dominant hand was recorded. The children's hands were cleaned again, and then they were permitted to play indoors for an hour. After the 1 hour of indoor play time, the amount of lead on each child's dominant hand was measured. So basically, they play outside. We measure how much lead they have on their hand. After they've played outside, their hands are cleaned again, and they're nice and clean. And we measure the amount of lead on their hand after they played inside. So basically, we have a case where the children are being tested twice. And because you are being tested twice, we're thinking this is probably going to be a paired t-test because you got tested twice. We have a before and after. They're tested once outside, then later they're tested inside. So we're looking for 2 data sets, and we'll see that we have that here. The data for the amount in micrograms of lead on each child's dominant hand are shown in the table below. So once again, we look at it and we go, okay, they told us there were 9 children, and 1, 2, 3, 4, 5, 6, 7, 8, 9. And I look at it and go, you know what? I have 18 numbers, but that's because they were measured once outside, and then they were measured again inside. So they were measured twice. So this is, in fact, a paired t-test. All right. So then what does it ask us to do? Using the data above, determine whether or not the amount of lead on a child's dominant hand is greater after having played outdoors. Test at 0.10 level of significance. So they're telling us alpha equals 0.10, and part A is telling us to run a hypothesis test. Okay, so since it's telling us to run a hypothesis test, they say specifically run a test. Test is at 10% level. We're going to need to use our recipe card, and because it's a paired test, we need to use one of our paired recipes. So the very first thing it says do is write your hypothesis. Well, the nice thing about a paired test is the null hypothesis is always going to be the same. So in this case, mu d, I should write HO, mu d equals 0. It'll be the same every time. And then it's going to be HA, and we know it's going to be mu d, and we also know this is going to be 0. And this is just saying, hey, the mean difference is 0, or there is, saying there is a difference, no difference here. This says the difference is 0, there is no difference. And then here they said we're going to go outside minus inside. And we expect the outside to be bigger and this to be smaller because they're expecting them to have more lead outside. And the reason we know that is they said higher outside than inside. So higher outside than inside. So this means this is bigger is greater than. So this gives me the direction here of a greater than. All right. That's probably the most difficult part, is making sure that we actually have that greater than symbol. The next thing we need to do is define the parameter in context. Well, our parameter is the mu d, so we always write let mu d equal, and this is going to be the true population. And we have mu for mean, so mean. We had to add that little d, so this is going to be the true mean difference. And what true mean difference? Of lead exposure. And really, it's lead exposure on the dominant hand, but I don't think we need to be that explicit. I think we say let mu d equal true population mean difference of lead exposure, but we have to say the order, and the order we went with is outside minus inside. And really, for test purposes, we're going to be pretty nice to you. And if you go the first row or the first column minus the second column, you should be good to go. So outside minus inside. All right, so we've done that. So the next step says for our recipe goes, because we've now done the first two, it says write the equation. All right, well, also we're supposed to give our conditions, and our conditions in this case are assumed. So our conditions are assumed, we're good to go. We don't have to worry about them. We say they're met for a regular stat, but we do need to write our equation. And our equation for this is just a t statistic, but instead of just being a t, because a t is going to look like t equals x bar minus mu s over the square root of n, we're working with a d, so we need to come back and drop a d in those places. We don't drop one for the n, but everywhere else we need to put a d in there for our equation. The next step says enter data if given. And if we look at this, sure enough, we're given data, and we're given two columns of data. So we're going to need to go to our calculator, and we're going to go to stat edit. And if you notice, I have extra data in there, so I'm going to go over and just remind you how to get rid of that. So if you have extra data, just go up to the column that you don't want and press clear and enter. And there you go. It's gone away. All right, so in the first column, I'm going to put my outside data. So in L1, I have all my outside data, 15, 25, etc. And then in the second column, I'm going to put my inside data, and that's going to be my L2 column. So I've already input that data. Now, we always give you some check values. Sometimes I have typos. I'll make sure there's not one on a test. But these are check values to make sure that you have your data input correctly. So not required to do this, but it's probably a good idea to just make sure you have your data in correctly. So if I go stat, calc, one variable statistics, well, I'm interested in the L1 column. So second one, the second followed by the number one. And I press enter a couple times. And sure enough, I see X bar 17.555, and then I see a standard deviation of 4.61. That checks out. So that means I entered that data correctly. It's like, well, you haven't done L2 yet. So we're going to go back to stat calc, one bar stat, and press second, followed by the number 2. And sure enough, I see 14.55 and a standard deviation of 0.8457. So you can sit there and go and know that you've entered your data correctly. Technically, we're not going to use this for the test or anything. This is just for you to make sure that your data is entered correctly. And so the next thing says on the recipe, it says find XD, etc. Well, at this point, I kind of skip ahead. All right, I'm going to skip ahead and do a bunch of work all at once and see if this helps you out. So we're going to go ahead and run the test, stat, test, and it really is just a t-test, which is number 2. And I see stats is highlighted. I don't want stats highlighted. I want data highlighted. So I'm going to press the arrow over, Just the arrow on the calculator over and press enter. Data is now highlighted. Well, it asked me for my mean. Well, that's a good question. What is it? Well, I need to make a list of all my information. And sure enough, I know that mu d equals 0. And guess what? The nice thing is it's always going to be that, and it comes straight from here. So this is that mu d, so that asks for that, so I'm going to type in 0. Then my list, it's going to say, okay, where's my data in? Well, the data I'm interested in is an L3, and you're like, wait a second, you haven't done that yet. You're right, I haven't. So let's go back to stat edit, and let's go to the top of L3 because we didn't have anything in there yet. And this is where I'm going to do my subtraction, because what we said was we wanted to do outside minus inside. So this means we're going to do L1 minus the L2. So second followed by the number 1 minus second followed by the number 2. And there, populated all my list. So now I have all this information in there, and I just basically subtracted. 15 minus 16 is -1. 25 minus 15 is 10. So it did all the subtractions for me. So we're going to go over to stat test again. We're going to run this t-test. We've already hit data. We already said the mean is 0, but the list I'm interested in is where I subtracted, which was L1 minus L2, and I just pressed second 3 because I put it in L3. Now, what do I use? Here I had a greater than, so I need a greater than symbol. So make sure that's highlighted. And then I press calculate. So I get a bunch of information and I want to start writing this down. All right. So first off, X bar, because that's one of the things on my list of things that I need. I need X bar D, which in this case is 3. I need the SD, which in this case is 4.854. I need my N, which is 9. And let's not forget about this, but degrees of freedom, it didn't ask for it, is going to be 9 minus 1, or just 8. All right, and then we also got some other values. And we have T equals 1.854. And we also got a p-value equal to 0.0504. We don't need these just yet, but I thought we'd write them down since we already have them. Now that I have this information, I can go ahead and plug this into this equation. So I'm going to plug in all my values. So we're at step 7 already. And I want the probability that T is greater than. You're like, well, how did you know it was greater than? Well, that's what that said right there. So I'm going to put that there. So the probability T is greater than, well, what was XD? Well, it was 3 minus mu D, 0, SD, 4.854, over the square root of 9. Well, what does that equal? Well, we already calculated that over here. So we already got that information. So that's the probability that T is greater than 1.854. And if you forgot where that came from, we'll do that real quickly. Stat, test, t-test. And we have data highlighted. Our mean is 0. We got column L3. We have our alternative hypothesis inequality, which was a greater than. Calculate 1.854. And then there's our t statistic, and that's our p-value. So that equals 0.0504. And this is our p-value. Okay, so I need to compare that. The next thing is I need to compare that to an alpha. Well, what was our alpha level? Well, I need to go back and look at the problem. And they said alpha, our level of significance, is 0.10. And remember, level of significance is just another way to say alpha. So alpha is 0.10. Always take a moment and make these the same length. So 0.10. So this is 4 decimal places. So make this 4 decimal places. Well, I see that 504 is less than 0.10. So whenever we have a less than, we reject the null. So our decision is to reject. If this is a less than, the p-value is less, and you're like, how do I remember that? If the p-value is less than alpha, reject the null. All right, so it happens to be a less than, so we're good to go there. Then the next thing I need to do is, all right, so that since now that I have that, since I already have reject and null, we're going to go ahead and write our sentence, our conclusion. So our p value is, well, what was it? 0.0504. What was our decision? We reject the null. There is significant sufficient evidence at alpha equal to 0.10 to suggest that the true population mean, be careful here, we need the word difference, don't forget it, all right? And you're like, hey, how do I remember if I need a difference or not? Well, if it's a paired test, you need a difference. Or basically, if the equation required the D, so you need to make sure that you have mean difference. Mean difference of what? We'll look back at our sentence of lead exposure then what? Lead exposure, what order? We always have to put our order outside minus inside. And if you want to write the word minus out, you can, but outside minus inside is what? Well, what was our symbol? Great, our symbol up here for alternative was greater than. So we're going to write is greater than 0. All right. So our p-value is 0.0504. We reject the null. There is sufficient evidence at alpha equal 0.10 to suggest the true population mean difference of lead exposure outside minus inside is greater than 0. In other words, they have more lead outside than inside. Okay, so simplified, there's definitely more lead outside than inside. So in this case, there is more lead outside than inside. And remember, what were they worried about when we read this thing? They were worried that it was higher outside than inside, and we supported that. So we support the alternative, that there's more lead outside than inside. We're supporting the alternative. All right, so that was part A, and that's the long part. It says using the data to determine whether or not the amount of lead dominant hand is greater after having played outside. So the next part says, part B says, construct a 95% confidence interval for the data and explain its meaning. Well, first off, we've already done a whole lot of that. We've already defined the parameter. All right, and we said the parameter was let mu d equal the true population mean difference of lead exposure outside minus inside. I'm going to write that down again. You don't have to because you've already done it above, but I'm going to write that down again because we need to make that distinction. So let mu d equal the true population mean. And remember, because we're working with a paired, we need to add this little word difference. All right, we only need this word difference when we're working with a paired. Mean difference of lead exposure outside minus inside. Right, we always have to include that. And in our case, again, that's going to be L1 minus L2. But we've already entered our data. We've already addressed the conditions and said that they were assumed. So the next thing we need to do for the confidence interval is write our equation. Well, if this was a regular confidence interval, we would be writing X bar plus or minus T star S divided by the square root of N. This is what we would normally write. But because this is a paired, we're working with that keyword difference. So I need to put a D here. All right. So enter the data if given. Fortunately, we've already done that. The next thing says find X bar D. Well, we've already done that as well because we went stat, edit, and we got all this information. We put it all in L1, this all in L2, and then we went to the top of L3 and we went second one minus second two. We did all that and got those answers. So then I need to go up and go, all right, how do I get that information? Well, the easiest way is to go ahead and take the shortcut, which is going to be stat, second quit, stat, test, and we're going to drop all the way down to number 8, which is a T interval. Data needs to be highlighted. My list is L3. And if it doesn't say L3, remember that's where the subtraction is. And then we need to put our confidence level. Well, what size confidence level? They said a 95%, so we can just go and use the 0.95. And I press enter. And we're going to get some information that we need. First off, we need X bar D, which in this case is 3. We need our SD, which is 4.854. And N is 9. And don't forget our degrees of freedom, because you're going to need it on this one, is in 9 minus 1 is 8. And while we're here, I'm going to write this information down as well. So we have negative 0.7312. And then we have 6.7312. Now that happens, we don't need that just yet, but that happens to be our interval. And this is going to be our lower and our upper, and we'll come back to that. But what I need right now is this information. And I'm going to start plugging into the equation. Well, I plug in and I go, okay, this is 3 plus or minus. And I notice I don't have T star. I'm going to come back to that in just a second. SD is 4.854. Then I have the square root of 9. But we have a problem. We don't have T star. So let's write that down, and we're going to go calculate how to get T star. Well, T star, to do that, you're going to go second vars. And this screen should show up, and you're going to drop down to number 4, which is inverse T. And it asks for the area. And this is where you're going to go parenthesis 1 minus 0.95, close parenthesis, divided by 2, and then ask for our degrees of freedom. Well, our degrees of freedom are 9 minus 1, or if you just want to type in 8, that's fine as well. And we end up getting T star is negative 2.306. So I can write that over here, negative, and always, we always make it positive. So always make that positive. And so when you're putting it in on your test, make it positive as well. So 2.306. Well, that gives me my interval that we already calculated. So we already have our interval. So we have our interval of negative 0.7312 to 6.7312. So we have our lower and our upper, all right? So it says construct the interval. Well, anytime you construct the interval, you're going to have to take the time to write the conclusion. Well, our conclusion is we are, well, what was our confidence level? 95%. 95% confident that the true population mean difference, is mean difference of lead exposure the order was outside minus inside lies within the interval. Well, what was our interval? Negative 0.0312 to 6.7312. Now we need to be careful and say, did it ask us to explain the meaning of the confidence level? And it did. So that means I have to explain the meaning of the confidence level. With the meaning of the confidence level is step 11. This was step 10. And so step 11 is, that's when we're going to do the in repeated sampling. And I always say this is my brag. In repeated sampling, we expect this method to capture the true population mean, and once again, because it's a paired, mean difference of lead exposure, 95% lead exposure. I'm sorry, I left off one part. Which way? Outside minus inside, 95% of the time. All right. So now we've done part B, and part C is the confidence interval consistent with the hypothesis test? Well, the hypothesis test, what did our hypothesis test say? It said there is more lead outside than inside. That's what we came up with. Well, what about our confidence interval? So part C, because the confidence interval, now let's look at it. What was our interval? So I'm going to write confidence interval, and then I'm going to pause and I'm going to take a look at the interval. Well, our interval was negative 0.07312 to 0.67312. And I notice it contains 0. Oh, it contains 0. Because it contains 0, because the confidence interval contains 0, We cannot say there exists a difference in lead exposure. All right, we cannot say there's a difference in lead exposure. But over here, we said there is more lead exposure. Over here on the hypothesis test, we said there is more lead exposure. So the interval is different outcome, or has a different outcome than the hypothesis test. Okay, so the interval has a different outcome than a hypothesis test. All right, so that is our answer to part C, and that is our first video. The first two videos will be the long videos. This will be, and that's probably the longest of the videos. Thank you, and I'll start the second one here shortly.